It's lesson time, yes? Happy lesson time. Here again. I am combining lessons 15 and 16. If you got a problem with that, okay, fine. All right, so here's why. Because lesson 15 is just to express money amounts as decimal numbers. And guess what I've been doing for you all through those 14 previous lessons when it wasn't even required? That's right, I constantly was hopping on the money thing. And so you've already gotten that pretty well. And the crux here is lesson 16, where we're going to apply, as we always do, what we've learned to solving word problems. In this case, involving money. So that's where our focus will be, is on lesson 16, although we will touch on lesson 15 as well. There is a sprint for lesson 16. If you're doing that, go do it. Have a great time. Do side A, mark number correct, mark correct, okay. Here's our little warm-up. Speaking of money, by the way, speaking of money, so 2 quarters, 4 dimes. What you gonna do about that? All right, 2 quarters is 50 cents, 4 dimes is 40 cents, 50 and 40 are 90 cents. Okay, great. And now if we were to write it in decimal form, see I use the ever popular cent symbol, and little fun fact here, the cent symbol comes after the number, whereas the dollar symbol comes before the amount. Interesting, isn't it? Do you know why? I don't. Okay, so 90 cents, let's write that as a decimal with the dollar symbol. So then dollar symbol comes first, 0.90 cents is how we'd read this, okay? All right, so yes. Let's move on. 130 cents. Well, what's that in decimal form using a dollar symbol? Conveniently placed there for you. 1.30 is how we'd write it, $1.30. Or if this were not money, we would say 1 30 hundredths, but it is money. Okay, so 3 quarters and 7 dimes. Oh boy. You know, I look at this and I think, oh, well, you know, can I find a better way of doing it? I would look at the 3 quarters and say, let me set one of those quarters aside, because 2 quarters, right, is 50 cents. And then from the 7 dimes, well, 5 of those will get me to $1, and 2 more dimes, numbers 6 and 7, will get me to $1.20. And then I have that quarter I set aside, so $1.20 plus 25 cents, $1.45. So 145 cents, which I already said in decimal form would be $1.45. See, so what you can do even mentally, especially on paper, is break it up in a way that makes it easier for you to do it. We could have done 75 plus 70 and gotten 145 just fine. But, you know, the mind moves in a mysterious way, doesn't it? So let's get right to it before you tell me I'm talking too much. Hey, I heard that. All right, so we're going to solve some word problems involving money. Money. Here we go. Miguel, rich fella that he is, has $1, 2 dimes, and 7 pennies. John has $2 bills, 3 quarters, and 9 pennies. How much money do the 2 boys have in all? This is pretty straightforward. In all, right? So we know we're putting it all together. Should we draw 1 tape or 2? Well, I think that's a matter of preference. I think drawing 1 tape might get a little confabulating because we have all this stuff going on. So I think 2 separate tapes will do better here. We could draw 1 because we are adding. So here's Miguel. He's got $1, 20 cents, 7 cents. John has $2, 3 quarters, which we know is 75 cents, and 9 pennies, which is 9 cents. Lovely. Okay, so how much do they have in all? There should be a bracket here. Who left off the bracket? Hey! All right, so there should be a bracket here with like M for money. So we get Miguel, $1.27 plus John, $2.84. We just set that up. We can do it this way. Let me show you a way of doing this. 1 and 2 are 3. Then add the 27 and 84. We get 111 cents. And then we can decompose out, right? Because that's 111 100ths, right? We can take out that 100 hundredths. We can pull out the 100 cents, the dollar, which would make it $4, right? So there's the 100 cents, leaving 11 cents. $4.11 is what they have all together. Written like that in monetary decimal form. Miguel and John, our statement, have $4.11 in all. Lovely, great, right? Okay, let's look at the next one. Sulin needs $7.13 to buy a book. In her wallet, surprisingly, she finds $3, 4 dimes, and 14 pennies. How much more money does Sulin need to buy the book? So we know she doesn't have enough. In fact, in a glance, she only has $3 bills and some change that clearly don't amount to $1, so we know she doesn't have enough. All right, so let's look at this one. So we know how much she has, and we know how much she needs. So there's the total in our tape diagram, is what she needs. This is the part she has. And remember, known part, unknown part, and we know the whole. That sets up subtraction, that this minus this will leave you with B, which of course is for buy book. Okay, so what are we doing? Right, yeah, I just said subtraction. Okay, so we're going to subtract here. So 3 minus 4 is 1. Ha ha, did not fool you. Very good. We need to regroup there. And if you ever get confused, hold up the 3 fingers and be like, can't take 4 away from that. All right, so we, yes, cross out that 3, go next door to the 1. The 1 is now a 0. The 3 is now 13. Now we can subtract. Minus 4 is 9. 0 minus 5 is 5. Oh, couldn't fool you that time either. No, we need to regroup there. We cross out the 7 and leave 6. Bring it over. This is now 10. Minus 5 is 5. This one we can actually do. 6 minus 3 is 3. Ask yourself, does the answer make sense? Yeah, you might even see that, this is about $3.50, which doubled would be 7. So 3.5 and 3.5 make 7. Or if you just rounded, like a raw rounding, this would be 7 minus 4, and we get 4. It's close enough, right? Okay, we're in the right ballpark. If you got something like $35, you know, woo, something's wrong, right? All right, so then all we need then is a statement saying, hey, Sulin needs $3.59 more to buy the book. Okay, so far pretty straightforward. We added 2 things, we subtracted 2 values. One-step problem so far. You know it always gets more complicated. I do want to look at this one again, though, to show you another way of thinking about this. We could have taken that $7.13 that she needs to buy the book and decomposed it as a method of subtracting. So if we said, hey, all right, it's $6, 113 hundredths, or cents, right? So all I did was take one of those dollars and convert it to 100 pennies, right? All right. Got that. So now you could subtract without the regrouping so much. You could do 113 minus 54 leaves 59. And then 6 minus 3 is 3. Right? So there's our $3.59. So another way of doing that, and I bring that up because we did do that back in fraction land. Great? Okay, moving on. Vanessa. All right, we can see this one's longer. So we know we're probably looking at a 2-stepper here, right? Vanessa, God bless her heart, has 6 dimes and 2 pennies. Good job saving up there, Vanessa. Joaquim has $1, 3 dimes, and 5 pennies. Nice. Jimmy's been working hard, has $5 and 7 pennies. They want to put their money together to buy a game. What game? You don't need to know. It costs, though, you do need to know, it costs $8. Do they have enough money to buy the game? If not, how much more money do they need? Well, let's make an assumption here, because we know how they write these questions. Obviously, they don't have enough money, right? Because if they did, they wouldn't say how much do they need. And in fact, you can do a quick estimate here. This is less than $1. This is a little more than $1. This is just over $5. So they have like $5, $6, maybe $7. Maybe 7 and change at most, around $7. So we can get a sense with a rough estimate that they are going to fall short. So when we go to, and I bring it up because when we go to draw our tape diagram, we're going to keep that in mind. So here are their respective amounts. Vanessa's 62 cents, Joaquim's $1.35, the 3 dimes and 5 pennies, and Jimmy Boy with his $5, 7 pennies. Okay, and we're putting all that together. Now, we can see we're putting all that together, right? But what's the question? Oh yeah, do they have $8? So there is a comparison here. So we do need a separate tape for the $8 because we're comparing the two. And what we want to know is, yes, the difference between them. And we're going to call it G for game. You got game? They don't have game. No. All right, so let's put together their three amounts to start with. 62 cents plus $1.35 plus $5.07. All right, how can we do that? Well, we can say, hey, look, here's $6, $1 and $5, like putting the $1 bills together. Here's 62 cents, 35 cents, 7 cents. Add those up, you get 104. Now that's more than $1, so we can decompose out the dollar, right? The 100 cents, leaving the 4 cents. So now we have how many dollars? $7, 4 cents. And we can see, yes, indeed, our rough estimate was pretty spot on there. So we can now figure out what the difference is between them. Yeah, can you see a way of kind of looking at this? That it's going to be, oh, well, it's basically $1 minus 4 cents. So what's 100 minus 4? It'll leave 96 cents. So that is all they are shy. The $7, 4 cents they have, subtracted from the $8 they need. And here's a way of looking at it. Show you this again. You can decompose it. Say 7 minus 7 is 0. 100 minus 4 is 96 cents. Then you need a cute little statement. We'll write it in decimal form, of course. Cute little statement saying, hey, they don't have enough money. Notice that statement answers this question. You have to do that. They need, answering the second question, 96 cents more to buy the game. So do you think that's the last one we have to do? Let me think. No, okay. So now, this is one where it is going to be multi-step, but also one where you have to pay attention or you can mess things up. So a pen costs $2.29. A calculator costs 3 times as much as the pen. How much do the pen and calculator cost together? Okay, so that seems pretty straightforward. We can get the calculator is 3 times as much. So here's our pen, $2.29. Calculator is 3 of those, right? That's the total for the calculator. Do we know how much the calculator costs? Well, not yet, right? We have to do that math, but that's what we want to find out. Oops, somebody gave you the answer. All right, so when you do that, one way you can do this actually in your head is 3 times 2 is $6, right? 29 cents, let's round it off to 30 cents. Because we can do 3 times 30 is 90, and then subtract out the extra 3 cents. 90 minus 3 is 87, so $6.87. Could you set this up in multiplication? You know how to do 3-digit times 1-digit multiplication? Sure. But you can do it in your head as well. $6.87. And we tell you, if I were writing this as a quiz, that would be wrong answer A, right there, would be $6.87, because that's not what the question is asking. How much do the pen and the calculator cost together is what it's asking. That's our total. All right. So now, way of doing this is to get rid of the decimals so that you don't confusicate yourself. $2.29, well, that's 229 cents, because that's a little easier to work with. Wait, where'd that 4 come from? Crazy man, where'd you get that 4? Because look, 1, 2, 3, 4. So this is another way of approaching this question. Instead of finding a calculator by multiplying by 3 and then adding a fourth, $2.29, you can just do 229 times 4. Boom, you get 916. And you can go ahead and do the multiplication yourself. I'm just showing you. Now, where would our decimal point go? There are a couple of ways of approaching this. I like using a method I call cents, as in S-E-N-S-E. Like, what makes sense? Yeah, calculator and pen, are they going to cost $91.60? I hope not. Are they going to cost $916? Whoa! Not stores I go to. $9.16. That's where the decimal point goes. And there are other ways of being sure of that. And then we just need simply a statement saying that, yeah, the pen and calculator cost $9.16 together. In fact, a rough estimate, 4 times 2 is 8. We're in the right ballpark. We got 9 and change, right? If we got 90, we know we were way off. And that even wasn't the last one. Because Krista has also been working hard. And she has $7.32. Mallory, we're assuming they're friends, has $2.04. This, my dear ones, this is a question. Yeah, I've been teaching Eureka math for several years now. This is a question that, and I've had some brilliant students. This is one that seems to cause a lot of confusion, just in terms of like, how do I do this? Okay, so this one I'm really going to walk you through. This one is a little confudulating. So what we want to do is, Krista is like, hey Mallory, you are my dearest friend, and I believe in equality, and I think we should have equal amounts of money. So I'm going to give you some of my money such that we have the same amount of money. And Mallory's like, free money? Right on, sister. I'm in on that. So the question becomes then, well, how much are you going to give me? So that they have the same amount. See, so it becomes a little, oh, how does that work? Let me walk you through and show you a way of thinking about this. Okay, so here is Krista, her $7.32. Here's Mallory's $2.04, okay? Now, the amount of money she's going to give her, this is why I drew 3 partitions here. The amount of money that Krista is going to give her, picture if this was like butter, and I sliced the butter and I brought it over here to Mallory's, then they have same amount of butter, right? Okay, but it's money, so I'm going to take this much of Krista's money, bring it over here, and now Mallory and Krista have the same amount of money. Now do you see how to calculate this? You see how valuable these tape diagrams are sometimes, because it shows you exactly what to do. And what do we do? Okay, well there are, again, a couple ways of going about this. We can take her $7.32, subtract Mallory's $2.04, and that will give us what 2/3 of Krista's money is, okay? When we do that math, and I'm just walking you through the logic here, so I'm not having you do the calculations, you get $5.28, okay? 7 minus 2 is 5, 32 minus 4 is 28, great, okay. So let's call that 528 cents so we can work a little more flexibly with it. All right, so now that means these 2 blocks are 528 cents. Yes. If she gives half of that 528 to Mallory, again, picture this block moved over here, then they will have the same amount. So what you have to do then is take the 528 and divide it by 2. Yeah, you see how that works now? I hope the logic is making sense here. And again, I'm not going to go through the long division with you here. I'm just going to show you what the outcome is. You can do the math yourself later. You end up with 264 cents. And obviously, where's the decimal point go in the money, right? That'll be $2.64. See how that works? So each of these is 264, 264, 264, adds up to, 204, 264, 264, adds up to 732. And so she takes that 264, hunkers it on over to Mallory there. And then she has 204 with 264, a total of 468. And yes, indeed, you see that? If we take the 732 and subtract out, we end up with the same thing there. So 264 is the M amount that we need to move over to Mallory. That's a wacky one, huh? Well, you'll be glad to hear it was the last one. So here is the exit ticket. Just has one question, and this is a very straightforward one. Just, he finds this much money. How much is it altogether? That's it. I mean, that's like, boom, done. And then you get to the homework, and do head over to my homework time video to do this with me step by step. Here we're just combining. Here it's, she has this, how much more money, subtracting, right, okay. And then these are all similar to the ones that we just did. We have 3 guys putting their money together. Do they have enough money? If not, how much more do they need? Just like the friends with the game before, now they're buying a book together. Okay, so now we have, just like the pen and the calculator before, now it's mechanical pencils and pens. So how much do they cost together, again? And then we have this one. Number 5 is just like that tricky one we just did, where this guy has this much money, she has that much money. How much does he need to give her so they have the same amount of money? Yeah, so that one is tricky. The logic there I give you is a little complex. But guess what? you've gone and done it again. You finished another lesson time. Congratulations to you and your doggy too. I will see you again in Module 7. Next time, it is once again lesson time.